Let's talk about some models we use to think about computer systems. Some of the most basic models in computers are bits, bytes, and words. A bit is a single logical or Boolean value. We think of it as true or false. In the hardware, it's represented by a logical 0 or 1. 0 for false, 1 for true. A byte is a set of 8 bits. We typically number bits in a computer starting at 0. So the bits in a byte are numbered 0 through 7. Each bit in the byte has its own value. We use word to describe strings of bits that are not necessarily 8 bits long. So a word may be 16 bits or 32 bits. And we would talk about the bits in the word as being numbered from 0 to, for example, 31 for a 32-bit word. Memory is addressable. So at location 0, we have a value equal to 3. At location 1, in this case, the contents of that memory location is 14. We can use bits, bytes, and words to represent many different things. A single logical value in the case of a bit, or a vector of logical values in the case of a byte or a word. We can use them to represent numbers. We can use the same bits to represent characters, an instruction, or an address in memory. The meaning of a set of bits is determined by how we use it. The instruction set architecture of a computer describes the operations that the computer can provide. The microarchitecture is the structure that executes these instructions. We'll see that we use clocks to provide us with synchronous logic that will help us design these complex computer systems. We use several abstractions to think about applications and how they're implemented on computers. An algorithm is a sequence of abstract operations that performs a desired function. A program is a set of instructions and data that implement the algorithm. The program, in turn, is implemented as a set of instructions that execute on the computer. Here's a piece of a simple program in the C programming language. It's translated into a set of instructions. These instructions do what the program says, but as you can see, it's much simpler to write the C code than it is to write the instructions. Programs perform input and output operations on devices. A program, for example, puts out some output that may be a string that says, "What is your first input?" Then receives from an input device some data, operates on it, then sends an output that says, "Your answer is X," and then it may receive some more input. This is a schematic diagram of some logic. Each of these symbols is a logic gate, and they are connected together using what we call nets or wires. These logical gates perform Boolean functions. They are the basic building blocks of computer hardware. Here is a block diagram of a typical laptop or desktop computer. It includes the CPU and memory. It includes several types of input and output devices. Storage provides long-term retention of both data and programs. The display allows the computer to draw and print things. And we have several other devices, including a keyboard, a mouse, and perhaps a webcam. Here are two simple computers. On the left, we have a Raspberry Pi. On the right, we have an Arduino. An operating system, which we often call an OS, manages the operation of the computer system. The kernel provides core functions for the management of the CPU, memory, storage, and I/O devices. On top of the kernel, we have several different components. The file system provides storage for both data and for programs. Networking allows the computer to communicate with other computers. And the user interface provides utilities that help the user make effective use of the computer. We judge a computer system by more than just the functions it performs. We have many other characteristics that we're interested in. Power and energy consumption. Power relates to heat, energy relates to battery lifetime. The reliability of the computer system. One way we measure reliability is the mean time between failures, or MTBF. The programmability of the system, how easy it is to program. Its manufacturing costs, how expensive it is to build and deliver the computer. All of these characteristics and many others can be traded off during design. We may want to sacrifice one characteristic in order to improve another. For example, we may sacrifice some amount of programmability in order to improve the energy consumption characteristics of the computer. Thanks for watching.